All right, ladies and gentlemen, so our next section in chapter 6, title talks about inverse functions and relations. So the whole topic is all about what is an inverse today. So if you want to find the inverse relation, it's just a matter of switching x and y. That's all you have to do to find the inverse relation. So here's an example. So it says geometry. You're given the vertices of a triangle ABC can be represented by using those points. So we have to find the inverse of this relation and then also describe the graph of the inverse. So let's just graph it out and see what we're looking at first of all. So 1, -1, that's point A, and then we have 6, -1. 1, 2, 3, 4, 5, 6, -1. That'd be point B. And then point C is at 6, -6. So 1, 2, 3, 4, 5. Okay, there's point C. So we're looking at this triangle, right? So if you want to find the inverse, first of all, again, it's just a matter of switching your x and your y. That's it. So if I want to find the inverse to this relation, so A prime is what we're going to call it. A prime, if I switch my x and y, that'd be -1, 1. Put parentheses around this. And then B prime, if I switch around x and y, it'd just be -1, 6. And then C prime, if I switch them, I get -6, 6. So again, I'm literally just switching x and y for each of the coordinates. That's all you have to do. So if I plot out these points now, and then we'll talk about describing the graph of the inverse. So if I plot these points, -1, 1, here's A prime. And then B prime is at -1, 6. So 1, 2, 3, 4, 5, 6. Here's B prime. C prime is at -6, 6. So 1, 2, 3, 4, 5, 6. Going up 6, there's C prime. Okay. So if you kind of compare these images, right? Look at where A was and where A prime is now, where B was, where B prime is now, where C was, where C prime is now. What happens every single time that you have an inverse relation or an inverse function? It's always going to be a reflection over this line. So I'll go ahead and graph it in here. So passing through the origin with a slope of +1, it's always a reflection over the line y equals x. Every single inverse, doesn't matter what we're talking about, again, it could be a graph of anything, but it's always going to be a reflection over the line y equals x. So if I had to actually describe this, again, it's going to be a reflection over y equals x. Okay, every single time. And you guys will see more examples of that too once we kind of get farther into the lesson. But these next ones, so they even give you an example here, right? So given this relation, if you had to find the inverse, here's the inverse. So if you look at the x's and the y's, they're just switched around. So it was 1, 5, now it's 5, 1. It was 2, 4, now it's 4, 2. It was 6, 3, the inverse is just 3, 6. So just switch around the x and y. So find the inverse of each relation for this next one. So the inverse would just be 2, 4, switch them around, -3, 1, and then 2, 8. And that's it. It's as easy as that. Just switch around the x's and y's. The next one, inverse would just be 0, 3, and then 1, -1, and then 7, -5. And obviously, if you switch 9 and 9, it's still going to be 9, 9. All right, but that's your inverse. Just switch x and y. Pretty simple. But what if you had a linear function? So here's an example. Here's how we're going to find the inverse to a function. Okay, so find the inverse of f of x equals x plus 6 all over 2. So step 1, I'm just going to replace f of x with y. That's going to be our step 1. So instead of f of x, we're just going to say y equals x plus 6 all over 2. Because again, f of x and y, pretty much the same thing anyways. You're going to interchange those. So f of x is just functional notation, but that's just the same thing as y. Okay, next step, step 2. Now you want to switch x and y. Switch x and y. So in the actual equation, switch these two around. So where y is at is now going to be an x. So it's going to be x equals y plus 6 all over 2. And now your next step, step 3, to actually start finding the inverse, is you now want to solve that new equation. Solve the equation for y. Okay, so let's translate this down here. X equals y plus 6 all over 2. Now we want to solve this equation for y. So start getting y by itself. So first thing I'm going to do is get rid of the 2 in the bottom. So multiplying both sides by 2, canceling that out, you'd have 2x equals y plus 6. And now get y by itself, just move the 6 away, subtract 6, so we have y is equal to 2x minus 6. Okay, the last step is now you're going to replace y with, this is the notation for an inverse. So it says f to the negative 1 of x, but how we read this is read as being inverse of f of x. That's how you actually read that, the inverse of f of x. So if I just swap out, again, this is the actual inverse, but we're just going to replace y with f to the negative 1 of x. So the inverse of f of x is 2x minus 6. And that is our final solution. Okay, so let's try the next one. On the next page, so we want to graph the function, then we're going to write and also graph the inverse. So graph the original function first of all. It's just a line and slope intercept. So graphing that, you're starting at the y-intercept, which is positive 1. Slope, you're going up 1, 2, 3 to the right 1. All right, can also go down 1, 2, 3 and to the left 1 if you'd like. Filling up your coordinate plane as much as you can. Okay, so this is the original function. Right next to it too, I'm going to write that's f of x. That's our function. Okay, now go through the steps. So step 1 again, I'm just going to replace f of x with a y. Next, step 2, switch x and y. So it's x equals 3y plus 1. And now solve that equation for y. So we'd have, again, let me just write this down here. Okay, so start getting y by itself. First, I'm just going to move the 1. So subtract 1 on both sides. So we have x minus 1 equals 3y. And now divide everything through by 3. So cancel that 3 out. We have that y is equal to x minus 1 all over 3. Okay, step 4. Last thing we have to do, again, that is our inverse. But just replace y with an f to the negative 1 of x. The inverse of f of x is going to be x minus 1 all over 3. Okay, now we have to graph this, which in slope-intercept form, to graph this, right, what I want to do for this one, I'm going to split this up so I can actually see what my slope is and what my y-intercept is. So I can also write this out as being 1/3 x minus 1/3, because that's a 1x here. So if you split it up, write each term individually over 3, this is what you'd have. Okay, so now I know exactly what I'm graphing. And I'm going to change my color too. So starting at negative 1/3, that's our y-intercept. So that would be about right here. We'll just kind of estimate. And then from that point, we have to go up 1 and then over 3. So from here, positive slope going up 1 over 3 would be about here. Going up 1 over 3, 1, 2, 3 would be about here. Again, you could go backwards too if you want, going down 1 and then to the left 1, 2, 3. All right, but here is our inverse. Connect it all the way across, right next to it too, right, that this is the inverse of f of x. And again, you can clearly kind of see too, if I kind of draw in my line of reflection, y equals x, you can even visually kind of see how you're taking that original function and you're reflecting it over the line y equals x to get your inverse function. Okay, pretty neat. But moving on to the next one. So same steps here. So again, I'm just going to graph the original one. So I'll go back to my first color. So I'm starting at positive 2 on the y. And then from here going up 1 over 1, 2, 3, up 1, right 3, and then also going down 1 to the left 1, 2, 3, down 1, 1, 2, 3. Okay, so here's our original. This is the function given to us. Here's f of x. We'll label it. And now find the inverse. So again, that's just y equals 1/3 x plus 2. Now switch them. So x equals 1/3 y plus 2. And now start solving this new equation for y. So getting y by itself, first we're going to move the 2. So subtracting 2 on both sides. So we have x minus 2 equals 1/3 y. And now get rid of the fraction 1/3. So how you get rid of 1/3, you're not going to divide by the fraction, but you want to multiply by the reciprocal, which is 3 over 1 on both sides. So anything multiplied by its reciprocal, that's just going to be 1. So that's a multiplicative inverse. So we get that y is equal to, and then distributing over here, you'd have 3x minus 6. Okay, that is our inverse, but now write it as an inverse. Step 4, this is f to the negative 1 of x equals 3x minus 6. Okay, there's our answer. So we want to graph this now too. So graph your inverse. So we're starting at -6. So 1, 2, 3, 4, 5, 6, all the way down here. Slope going up 3 over 1. Okay, so here is our inverse. So next to it, we'll label it, that's our inverse function. And once again, you can clearly see that reflection over the line y equals x. Okay, you don't have to draw this in every single time, that line of reflection, but I think it's kind of helpful to see how this happens every single time. If you were to literally take that first blue line and reflect it over y equals x, you would get that inverse function. Okay? On to the next ones. Okay, so now we have to identify, do we have inverses, is basically what we're doing. So it says two functions, f and g. They're going to be inverse functions if and only if both of their compositions are the identity function. So what that is saying is f of x and g of x are going to be inverses if we do each composition. If I plug g of x into f of x, right? If I do that composition, I want the identity function, which is just x. So I want to be left with just a positive 1x in the end. And if I do the other composition, if I plug f of x into g of x, once again, I also want to be left with just a positive 1x. Okay, but you have to check both compositions. You can't just do one of them and then think you're correct. Okay, so checking each composition. So determine whether if these functions are inverses, right? So again, I'm going to do f of g of x to start. So find each composition. Again, I'm taking all of g of x, I'm going to plug it into f. So if I take g, 1/3 x minus 3, plug it into f of x, we would have 3 times 1/3 x minus 3 plus 9. Okay, now simplify this. Again, we want just a positive 1x left over. That's all we want. So as you start to simplify, if I distribute 3 to both terms, I would have positive 1x minus 9 plus 9. Well, minus 9 plus 9 cancel, and look at that. We have positive 1x left over. So far, so good. But now you want to check the other composition. So if we do it vice versa, if we do g of f of x, so now we're doing the opposite. We're plugging f into g. So going backwards. So now I'm going to take f of x, I'm going to plug that in over here into g of x. So now I'm going to have 1/3 times all that stuff, 3x plus 9 minus 3. Okay, simplifying again, distribute 1/3, so you'd have positive 1x plus 3 minus 3. And once again, these just cancel, we get a positive 1x. So we can officially say with confidence, since for both of them we're left with the identity, we can officially say that yes, these two are functions, or these two are inverse functions. Okay? So now same thing for the next one. So we have these two functions, so find each composition. So f of g of x, we'll start with that one. So again, I'm taking g, plugging into f. So that would give us 4 times 2 square root x squared. Okay, so when we plug 2 square root x into f of x, here's what we have. All right, so now simplify. So we have to square both of these. We're squaring that whole entire monomial. So this would be 4. Again, we're doing 2 squared. Square root of x is being squared. So that would give us 4. This would be 4. The square root of x being squared, that's just an x. These are inverse operations. They cancel each other out. So I just have the x left over, so I have 16x. So I can even just stop here because I did not get a positive 1x like I wanted to. I can just stop right here and say, well, no, these are not going to be inverses. Okay, if one of them doesn't work out right away, if you don't just have a positive 1x left over, you could just stop there. You don't even have to check the other one. All right, so same thing for the next one. Let's try this. So I'm going to do f of g of x again. I'll do it in this order. So g is going over into f. So I'm going to take all of g, plug it in this way. So I'm going to have 3 times 1/3 x plus 4 minus 3. Okay, so distributing, I would have positive 1x plus 12 minus 3. And this doesn't look good either. We have x plus 9 left over. So again, I can just stop right here. And I can just say, no, these are not going to be inverses. It's not going to work out. All right, now the last one. So f of g of x. Let's do this one first. I'm going to take g and plug it into f. All right, so this big guy, we're going to plug it in over here into x. So we're going to have 2 times this huge thing, x plus 1 all over 2. That's all being squared minus 1. Well, again, if I'm squaring a square root, Those are just inverse operations. I'm squaring this gigantic square root. So that's going to be 2. Okay, when I square that, all I'm going to have left here is x plus 1 over 2. So no more square root after I square it. Okay, I just have everything that's underneath the square root now freed. All right, so now the next part, when I multiply these two together, well, these 2's, this is 2 over 1 right here, these 2's just cancel each other out. When you're multiplying fractions, you can cross cancel because 2 over 2, that would just be 1. So what I'm left with now is x plus 1 minus 1, plus 1 minus 1 cancel, I have positive 1x. So again, so far so good. But now we got to check it the other way too. So now if I do g of f of x, so now I'm plugging in f into g. So let me scroll up just a little bit here so I can see the function. Okay, so when I plug f of x into g, we have this big square root, right? Underneath, we have 2x squared minus 1 plus 1 all over 2. Okay, so as you start to simplify this, on top, minus 1 plus 1 again just cancel. So now we're at the square root of 2x squared over 2. Well, 2 over 2, that's just 1. These can just cancel down. So now I'm with square root of x squared, and we know the square root of x squared by now. That's just going to be positive 1x. All right, so it looks like it works out. We get positive 1x, so this one would be a yes. Those two are inverse functions. Okay, so there's your lesson today on inverses. All right, let us know if you have any questions, and we'll talk to you later.